Welcome to All Space Considered, everybody. It is the third Thursday of the month. Yay! As always, I want to make sure that you know that All Space Considered is brought to you by Griffith Observatory, the Department of Recreation and Parks, and the City of Los Angeles. But we also like to thank our exclusive nonprofit partner, Griffith Observatory Foundation. Thanks to their contributions, much of what we do is possible here at Griffith Observatory and All Space Considered, so thank you. Tonight we have a really great show. It is the third Thursday of the month, and that makes it October 17th. And we have Astronomy News Bulletin. We're going to talk about a solar cycle news flash, the comet of the century, question mark, playing catch with a rocket, and then lastly, a Europa Clipper clip, which will be fun to talk about. And then we have a search for Planet 9, a status update with our very special guest, Konstantin Batygin, who's here with us from Caltech tonight. And also with me on stage is Laura May Abron as well, Griffith Observatory Museum Guide and All Space regular now as well. So we have a great show for you. Well, let's get it kicked off. We may as well begin the show. And also, by the way, if you have any questions during the show here in the audience, feel free to shout out, raise your hand. We're happy to interrupt the program and answer your question as we do the show. Even if we're kind of on a roll, we'll keep an eye out and watch for your hands. Those of you at home, feel free to ask questions of our moderator, and he'll do his best to answer your question. We can't easily pass them on to us yet, but we're working on that. Well, what was that image we were looking at in the background? Well, that's an image of the sun. Looks kind of funny because it's purple, but it's an image in the ultraviolet. This was taken by the Solar Dynamics Observatory, and it's a combination of several ultraviolet bands, actually, and it's showing a solar flare. That's that bright flash that's in the center of it, that bright spike of energy. And that's caused, well, we think it's magnetic fields that are rearranging, recombining, releasing huge amounts of energy, which create this bright, bright glow. It can glow in the visible light. It can glow, obviously, in the ultraviolet. These are associated with sunspots. And in fact, Laura May, there was just an announcement about something with this. Yeah. So why don't you take it from here? Because you're
very exciting solar news that dropped yesterday. So we are really on the cutting edge right now. We are officially in solar maximum. Now, for those of you who know a little bit about the sun, or if you don't, I'll just refresh your memory on this. Our sun's got a 22-year-long cycle throughout which it flips its poles, basically, right? So it's a lot shorter than on Earth. On Earth, this takes hundreds of thousands of years. On the sun, it's very quick. And the sunspot cycle, so those little black dots that you're seeing on the sun that are colder regions on the sun, this is an 11-year cycle. Now, our previous cycle, solar cycle 24, was actually the weakest in about 100 years. We didn't really know what was going to happen with this cycle. It's very hard to predict solar cycles. So it was pretty exciting when, I think around 2023, 2022, we started getting really the solar activity ramped up pretty quickly. And now we are officially at this time period that is called the solar maximum. So how long is that going to last? We don't know because we are in it, right? So when we've got a shorter solar cycle, this can last about a year or two. When we've got a longer solar cycle, this will last 3 to 4 years. Now, what does this mean, right? How does the solar maximum actually affect you? Well, it affects a lot of our technology. To be clear, it'll affect GPS, radio technology, things like that. In our daily lives, we probably won't notice it. That's also because a lot of investments were done to protect a lot of technology in the United States. But what's exciting is that it has led, as some of you may have seen on the news, to some amazing auroral storms, geomagnetic storms. You might call them also northern lights, southern lights. Most people don't know. They also happen in the southern hemisphere, but they're over Antarctica. So penguins, unfortunately, don't have phones to take beautiful pictures of these aurorae for us.
Not yet.
Not yet, but we're working on it, right? I don't know, did anyone in this audience get to see any of these solar storms, these auroras from anywhere in the United States? Anyone?
It was in New Jersey.
In New Jersey?
Yeah, it was.
Yep. Yeah. So I was lucky I got to see them from Los Angeles, believe it or not. On the 10th of May, they were visible from up at Mount Wilson. And I'm not kidding you when I tell you they were actually visible to the naked eye. Not as brightly as pictures. Sensors on cameras capture a lot more. But we had another storm, in fact, on October 10th.
Yeah, I managed to get a picture of it in New York City from Flushing, Queens, top of a hotel at a hotel bar, looking out at Manhattan, and I'm like, okay, I'm going to point north. Set a time exposure. Sure enough, there was a pink glow in the sky. Well, of the upper part of the sky, not the lower. The lower part, you might say, well, there were some buildings giving off red light, which there were, but no, it was white above those, and then way up high, it was pink. It was weird. So it was the aurora. Couldn't see it with my eyes, though.
And it's worth a note that they're not going to be green. The further south you are seeing them red because there's the curvature of the Earth, so you're actually seeing the top of it. But yes, do not panic. I know there's been, I don't know if you've seen any of them, there's been a lot of stuff online. Apocalyptic sun will destroy us and our technology. No.
This is actually a pretty weak solar cycle in the grand scheme of solar cycles. It's stronger than the last one, maybe stronger than the previous one, but it's still kind of a weak one in general.
Can I ask you a question?
Yeah.
Why is it all of a sudden that in the South, in North America, you can see it? Or instead of like up in northern Canada or in Norway and those places?
It's due to the coronal mass ejections. Let me restart this video here. And you can see in this video, there's some regions on the edge of the sun where there's some sort of sparkles going on and those streamers are coming out. Well, if you get a flare at the bottom of one of those, material can be blown off the sun completely. It's called a coronal mass ejection. That material flows into space, heads out, and if it happens to be pointed at us, which it's kind of heading off in a large chunk of space, it'll impact the Earth. And it actually bounces around in our magnetic field, and it creates the aurora borealis. So these ejections have been happening. This has been a stronger cycle than in recent memory. Again, it's been about probably at least 20, 30 years since we've had a cycle this strong. So it's been 30 years since we've been seeing aurora this far south, and now people have the cell phones to capture them. 30 years ago they didn't, and you wouldn't notice a faint glow with your eye. You go out with your cell phone because the internet told you there's going to be an aurora. Suddenly you're seeing, so that's part of the reason. The technology's improved, and it's a stronger cycle.
And rise of social media. People have been, I don't know about you, but my feeds.
Does it have to do anything with climate change?
No. Not at all.
No, not
connected. The sun is does give off a little more activity during the peak of this cycle, so it's a little stronger. We get a little more energy, but it's not, this is part of the normal cycle. It goes up and down, so this isn't causing it. This is actually the sunspot count, and you can see that big spike where we're up there. This is one of the things that led NASA to decide we're at solar maximum, and if it lasts a year or 3 years, we're not sure. But you can see how tall that spike is, and it's bigger than the prediction was for this cycle. So it has been stronger than we initially thought before this period began.
Yeah, there's some conflicting predictions between NOAA and UCAR, Center for Atmospheric Research. There's some interesting theories on terminators, on the sun, the way the magnetic fields are, that can potentially predict the next solar cycle. All of this is very new, and it is very hard to predict the solar cycle. But NOAA, I do want to say, have been doing an amazing job thus far. And the predictions, again, are relatively following. So now we're headed into a potential decline of activity at some point, but that's mostly for sunspots. The geomagnetic activity is going to continue. So I recommend to people that they pay attention, they get little aurora applications, they check out maps for dark skies, especially around the equinox. That's when we've got a very special relationship with the sun, and you might be able to see some auroras in the coming year. Hopefully we'll see more of them.
Yeah, and this movie I'm rerunning for you is another Solar Dynamics Observatory movie, and you can see this flare going off, these bright spikes of light. Those can give off the coronal mass ejections. Yeah, so question up in the top back there.
Yeah, I was just wondering, now I'm forgetting if it's just in theory right now or if they've actually launched it, but the solar sail satellite that they're launching, is this to actually aid in propelling the solar sail?
I don't know which solar sail you're talking about. I know Planetary Society launched one as a test one, but that was a few years ago, and it succeeded. They were able to navigate with it, move a little.
Yeah, they're on
but I'm not sure what they're doing with that. Those are mostly experimental craft for them to test the sails and things. I'm unaware of any research craft that are using solar sails at the moment. So I'm not sure. They may have some small research capabilities on them, but they're not NASA programs. I think they're privately funded to try and push the technology and show that it can work. So it's great they're doing it, but I'm not aware.
Yeah, I vaguely recall hearing about it. I don't know if it was a recent smaller project.
Yeah.
Yeah, but to answer your question, the kernel mass ejections will not contribute significantly because they're basically powered by radiation pressure.
Yeah.
Right. So they're light powered, effectively.
Yeah.
It's been interesting for the Artemis missions, though, because now we've detected, for example, on Mars, they had the strongest detection recently of an energetic solar event, and we obviously want to keep astronauts safe. The Artemis 2 should be launching next year with people, astronauts, Artemis 3 to follow. And so all of this needs to be monitored so we can keep astronauts safe while they're outside of the protection of our magnetic field.
Yeah, the mass ejections could be bad for astronauts if they're energetic enough. So we have to see on that. Moving on to our next topic, there's a comment.
Quick question.
Very quick, but we do need to move on.
Can you give me a sense of scale of the size of the flare that was on the right side?
That's probably 4 times the size of the Earth.
So it's a small one.
Small.
And it's a little one.
Small. 4 or 5. Yeah, sunspots can be Earth-sized, but that's up above, and you'd probably get a few Earths across it. Yeah. So anyway, there's a comet in our sky. How many people saw the comet?
Ooh, a lot of
you.
people.
Fantastic. How many of you came to Griffith Observatory to see it? All right, several of you did. Fantastic place. A lot of people were very excited to come here. They got to look through our telescopes and see it. In fact, Alan, who's here in the audience, got some great photographs through our telescopes and helped people see it. It was great. This picture was taken by...
This picture was taken by Anthony Persick, one of our telescope operators. He has a lot of really great shots. I think a lot of people here managed to capture it. And if any of you showed up to our star party, it was pretty incredible. I'd been looking out for it for a couple days and didn't see anything, and then on Saturday, it just appeared in the sky. And I have terrible sight, and you could see it very clearly.
Yeah.
It was pretty impressive.
This is a picture of it. I forget where this was taken. I want to say in Africa. I think it was in...
There's no light
from
pollution.
Africa,
So.
no light pollution. It was a dark sight, but you can see that tail that's pointing downward. There's the main one going up. There's another going down. That's called an anti-tail. Those are larger dust grains that are coming off of the comet and being left behind in the orbital path. Most of the material is blown off and pushed away by the solar wind, and so you're seeing the anti-solar direction. This one is actually that's where the comet happened to be, and it just is opposite from the comet's tail. And it's known as an anti-tail, and it had it briefly as we passed through the plane. You couldn't see it the next couple of nights. This was another photograph taken, and that wavering ion tail is really pretty, and that is affected by the solar wind, and these coronal mass ejections can push that around and cause kinks and things in it. So comets are affected by the sun a lot. And this one traveled pretty darn close to the sun in the grand scheme of things.
Yeah.
It came inside Mars's orbit, and
I forget what the exact distance was, but it was the second brightest seen on SOHO.
Yeah.
You just see it if you want to look up the SOHO footage. That's one of the probes we have out there. It just passes right in front. It's pretty amazing to see it. And it came very close and was at its closest approach to Earth on Saturday when the star party.
Yep, and this is the light curve of it. So each of those little black dots and blue dots are measurements of the brightness by different organizations. They put them onto a chart like this. Time runs across the bottom. It starts off in, December, so January all the way to October. And then it peaks very sharply in there. Part of that reason is, that's when it was close to Earth, so you get a boost in the brightness, but also there was this forward scattering, as it's called. The dust in the comet tail had the sun behind it, and if you get the sun sort of behind the dust, that tends to illuminate the dust, and anyway, it's brighter. It's like dirt on your windshield when you're driving into the sun. It looks really bad, and you think, I better clean that. Sun goes down, no big deal.
Dirty snowballs.
Snowballs.
That's you can see that it reached about -4 magnitude. Keep in mind in astronomy, we don't like to be logical, so we do things in reverse.
Yeah, but the -4 is a little deceiving because that's an integrated magnitude, and that was spread out over a huge area. So -4 would be brighter than Venus. It didn't look brighter than Venus. No, but it was a very bright comet, and people got some amazing photographs of it, like you did.
So this was an image I shot a couple days ago, just over the observatory. And I do want to say, I did not enhance a lot of this image. I enhanced a little bit of the colors of sunset, but I was there for a while. I tried to shoot it many, many times. In fact, 2 days ago, I tried to shoot it from our solar telescope. unfortunately did not get anything. It has dimmed quite significantly, so if you haven't seen it up until this point, go somewhere with really no light pollution, some good binoculars, you might get it. But it is dimming pretty quickly. So, you know, but it was incredible. I don't know if anyone's ever seen one brighter. Have you seen one brighter than this?
Oh yeah, way brighter.
Okay.
I
remember Hale Bop in '97. Hale Bop was way brighter.
Hale Bop was way brighter. I could see it from downtown San Francisco, naked eye with the tail. It was just there hanging in the sky. It was like, that's freakish. Haibatake was very bright for a few days, but I was also in the dark Santa Cruz Mountains up on campus. So, but it was
certainly
spectacular.
Of recent ones, I would say brighter than the one from 2020. Which one was that? Comet Neowise. I would say brighter than Neowise. I don't know.
I didn't get to see it, so it was cloudy on the day it was the brightest when I was in New York, and then I tried to see it my last night there, and it was barely visible in the pictures, so hard to say. But I don't know, Comet of the Century, there's a lot of this century left, so, you know, we'll have to see.
Every comet gets called Comet of the Century.
Yeah,
if you see that in the media, wait for confirmation before booking some trips. Ask me how I know this.
Exactly. Now, we have a couple of launch stories to talk about here briefly. The Europa Clipper got on the way. This is a mission that is headed to Jupiter and Europa's moon.
7, 6,
Jupiter's moon, Europa.
5, 4, 3.
Let's watch the
2,
launch here.
1. Ignition.
This is a
And
Falcon
lift
Heavy.
off. Lift off from Falcon Heavy with Europa Clipper, unveiling the mysteries of an enormous ocean lurking beneath the icy crust of Jupiter's moon, Europa.
Engine chamber pressures are nominal.
So this is going to get there tomorrow, right?
No.
No, it has some gravitational assist, some flyby of Mars, going to visit a few other places, and then reach Jupiter insertion on April 11th, 2030. So we got a little waiting to do, but that's okay. You don't have that much waiting. It'll get there eventually, and it's going to look into Europa, which has vapor coming off it, geyser, icy particles coming out, and they saw evidence that there's organics in those, so carbon molecules. This is a candidate for where life could be down in that ocean. So I think, Constantine, you were saying bring a fishing pole.
Yeah, bring a fishing pole, get a fish fry going, get some crabs, you know.
Yeah, maybe in 100 years, fishing on Europa, that'll be the destination.
It'll be the destination.
Yeah,
so
fishing in
it got on the way, and the main reason I'm bringing this up is join us next month for Dr. Robert Papalardo, who's the project scientist for the Europa Clipper mission from NASA JPL. He'll be here in this room next month, and he can tell you all about that fishing pole they're bringing to find those, well, just looking more into it. It doesn't really have a fishing pole, and they're not actually looking for life this time, but it's the first steps to do that research eventually. They've got to go scout it. They need to look at the moon in more detail. So it's an exciting mission. Come on back and hear it from the experts. But there was another launch that happened. This one was down in Texas, and this was kind of amazing. This rocket is bigger than the Saturn V. Keep that in mind. This is the largest rocket to have ever flown.
Wow.
I mean, it barely looks like it's moving, but the thing is going fast. It's just huge. And then this was, the top part went off, had a successful mission. But this was crazy. The booster coming back. And then Mechazilla catches it.
That's the name they gave it, Mechzilla.
Mechzilla.
I think Jared called it the chopsticks. Jared cannot
chopsticks.
be with us right now, our aerospace expert.
Hi, Jared. Hopefully you're watching. But yeah, those chopsticks came in and grabbed. That was the first attempt of this ever work, and they did it. It's anyway, reusability of something this large is big. It's expensive. All those 30 engines in the bottom of it. This is a big deal. So the fact that it's up and running is very, very exciting. Anyway, does anybody have any questions as he's getting the microphone finished here?
I can just speak loud.
Do you want my mic?
No, I think
Okay.
we're good.
So,
Mic
what's
check.
the mission of the last rocket that we just...
It was a test mission. So literally SpaceX is building this enormous rocket to have something called Starship on the top that will eventually take people to Mars, do all sorts of missions. But right now they're just making sure the thing can fly. So the top part went into orbit and then slowly lowered itself down into the ocean. So it did a safe landing on the water to test whether it could land. And then that booster, they were learning whether they can catch it to be able to reuse it. So it was an engineering mission.
Economics also are a big part of this, because when you have reusability, it's a lot cheaper to launch.
Yep.
So that is a big advantage.
So I know that SpaceX a couple years ago was testing landing their rockets on a barge.
Oh yeah, that works now. Yeah, they've done that dozens and dozens of times. Yeah, it's crazy.
Who is financing all of the SpaceX?
A lot of it is financed by the U.S. government by buying missions from them. So we're buying launches off of them. And we also funded a lot of the research. They were given money to help do the research. They were given information. It was the commercial crew things that we were doing, the research into having commercial takeover crew launches. So SpaceX took advantage of that and ran with it and was very successful. So congratulations to them on that. Yeah.
It is worth pointing out that they have built on the success of NASA
Yes.
for decades.
Yes.
You know, SpaceX is amazing, but they also are,
NASA had vertical landing rockets back in the 60s. So, I mean, the lunar lander is a vertical landing rocket. It landed on a rocket on the moon. And they did that on Earth before they landed it there. So this technology's been worked on, but it was never good enough to bring back a booster. So they certainly took it to the next level, but it's on the shoulders of the previous research. And they'll admit that, but the engineers there have been amazing. A lot of folks will want to credit Elon Musk for all of this, but he's one guy. No, I'm sorry. It has been an entire team of engineers that have been working in SpaceX very hard. And I want to give them credit for what they've done. It's been really amazing, and they're pushing the boundaries.
I read on this website, twitter.com, that it was just him.
It was just him.
He just put it together.
Yeah,
that's right.
So the folks have worked really hard, and they're opening frontiers. They really are opening frontiers, and I don't really love the fact they're polluting the night sky with satellites. I think maybe internet could be brought a different way, but it is what it is. Humanity does these things without asking astronomers, so go figure.
Astronomers can deal with it.
Yeah, we can deal with it, and I have to say it was nice to have high-speed internet out at Burning Man. So, anyhow, but it's time for us to turn to our guest. We've run a little long on this, but that's fine. We don't have anywhere necessarily to be.
I've
But
got time.
Constantine, so
Yes,
welcome
sir.
to the program tonight. Your topic, you told me, was the search for Planet 9, a status update. And then I threw this, what I think is maybe the silliest picture of it, but maybe not.
Of me or the planet?
Of the planet. The planet. It's a great picture of you
I mean, both,
with the leather
maybe,
jacket. But the planet, with the Milky Way behind being that big, I mean, how close would Planet 9 need to be to us to be that large in our sky relative to the Milky Way?
I mean, this is a picture taken from the night side of Planet 9, right? When it's like right there. Okay. And so look, for scale, right? Planet 9 is something like 600 or 700 times as far away from the sun as is the Earth. So it's kind of far away.
Yeah.
Okay. That's why it's quite dark.
Yeah.
But yeah, please.
What is it at all? I mean, you're one of the folks looking for Planet 9, but what started all of this? Why do we think there's a ninth planet? Do we need a ninth planet?
I mean, better have it and not need it than need it and not have it. Okay?
Spares are important.
Look, so maybe a good place to start the explanation of this saga is to kind of go to. Maybe we'll wait for this.
There we go.
Yeah. So if we kind of dial the clock back to the year 1992, right, when the first Kuiper Belt object after Pluto was discovered, it kind of gave rise to this new understanding that the solar system has a second asteroid belt. A lot of people are familiar with a belt of asteroids between Mars and Jupiter, which is called the asteroid belt. Okay.
Original.
But as it turns out, beyond Neptune, and Neptune is the biggest. The orbit of Neptune is the biggest pink circle that we see on the slide there. beyond Neptune, there's a second belt of icy asteroids, which is called the Kuiper Belt. Okay, and the discovery and characterization of the Kuiper Belt kind of sparked a lot of research in understanding how the solar system formed and evolved. And a fraction of my thesis was kind of dedicated to some of the modeling on the early evolution of the solar system. And what we've come to understand is that the giant planets, Jupiter, Saturn, Uranus, and Neptune, it turns out, started out closer to the sun than they are today. Okay? And this is work that was initiated by colleagues at the Nice Observatory. This is called the Nice model, which spells the same way as the NICE model. It is both, but the basic idea behind this new theory is that the giant planets started out closer to the sun, and as they plowed through this field of icy asteroids that encircled the sun early in its lifetime, the orbits expanded and eventually stabilized where they are today. And so what we see as the Kuiper Belt right now is the remainder of this material that got scattered out. Okay? So it's that last kind of 0.1%. And a lot of effort has gone into doing modeling of this kind and trying to understand, exactly how all of this happened. And by now, this model explains almost everything about the trans-Neptunian region, okay? And by almost, what I mean is that the thing that it doesn't explain is why, if you go far enough out beyond Neptune and focus on the most long period, kind of the longest orbits that we can see, why they all tend to lie in a common plane that's kind of tilted with respect to the plane of the solar system, and why they all point into a common direction. You guys can all also agree with this, right? You all see that they're all pointing in the same direction? Okay, so here's the thing. If you take the solar system as we see it today, and if you say, I'm going to run the clock forward for just a short little while, like a few 100 million years, all right? You just let it go. What's going to happen? Well, what's going to happen is these orbits will randomize, okay? They will start pointing in every direction. So only two possibilities arise. One, we shouldn't believe what we're seeing, okay? We can talk about that. Or this alignment that we're seeing is real. And if this alignment that we're seeing is real, then there needs to be a thing beyond Neptune that's causing it, right?
Well, so now you say every object out there all points the same direction. You didn't just cherry pick those and just show us the ones that are pointing that way.
No, of course not. And I should be clear, it's actually not a perfect pattern, right? So the data set since then has kind of increased by about a factor of 3. Okay, so this is what the outer solar system looks like now. So what we see is that this alignment is actually prevalent among objects that are dynamically stable, which means that they are not being kicked around by Neptune so much that they're leaving the solar system. These are kind of the long-term, members of the solar system, so they are well aligned. There are also some objects that are not, and that's okay. This is a statistical pattern. Okay. But however you do it, like whatever explanation you want to propose for this, if you really believe that what you're seeing is what's going on, then you need an external source of gravity. Okay? And that gravity can come, by the way, from anything. It can be a very big burrito. It can be a very big, planet. It can be anything.
Could it be a black hole?
So yeah, that has been proposed in the literature that what's going on is that the solar system has a black hole that's orbiting the sun. That's pretty exciting to speculate about, but it's probably not what's going on. It's just that black hole, like the moment you mention a black hole, like
You get
Everyone.
pressed.
Yeah, you get kind of you get amped up. But however you do it, right? However,
Well, there's no X-rays, so you probably see X-rays of a black hole that close.
Yeah.
And this helps you constrain the mass, right? Because what's your estimate right now for the mass of this particular planet?
It's about five Earth masses.
Okay.
Maybe it's 6, but it's probably 5. Okay.
Which
so
is
this would be like a mini Neptune, a sub-Neptune.
Yeah. And in fact, there's been a lot of work in the last couple decades on the question of why is Uranus tilted, okay? Which sounds like a completely unrelated question, right? Like the fact that Uranus spins on its side, right, tilted by 98 degrees with respect to the plane of the solar system. There was a band called 98 Degrees, by the way. It was popular between the year 2000 and March 2000. Okay. So, anyway, I assume they
named after Uranus.
Named after Uranus, yeah, of
But
course.
I don't know if you saw, there was a recent theory that this inclination, in fact, I think it was a paper out maybe from Paris Observatory, that potentially it had a little moon that drifted away from it and caused a resonance with it.
Yes. Yes. So the difficulty with the moon idea is that you then have to lose the moon because it's not there anymore. Yeah. And in order to lose the moon, you have to have a close flyby of another thing. So whether you do it that way or whether you invoke an impact, right? However you do it, the outer solar system was full of things that were 5 Earth mass, right? If you didn't know anything about the Kuiper Belt at all, right? To get the tilt of Uranus right, you have to invoke the existence of lots of these 5 Earth mass things. And, where are they now? Many of them have collided to create the Uranus and Neptune that we see today. Along that, if you do a careful calculation of this, you find that the accretion process pretty inefficient. A lot of them get scattered out, and 1 or 2 of them in those calculations routinely get trapped. So even if you had no evidence for Planet 9, the naive expectation is that there's sort of a 40% chance that something else is floating around with sort of at hundreds of astronomical units away from the sun.
Now, if that's the case, why haven't we found it? Because the evidence is there gravitationally. It's needed to sort of disturb all these objects. And the way to think of that, by the way, is if you had things sort of, you've seen those gravity wells where you release either a quarter or a penny and it spirals around, or a marble, and it orbits. Well, now imagine if you took the whole thing and tilted it. Everything that's orbiting will go closer to the center and kind of fly outwards. That's basically what's been happening here, is this 9th planet has tilted the gravitational field out there, causing all the objects to go flying out the other direction.
That's what happens in my bank account.
Exactly.
I put all my bitcoins and they all flushed into the gravitational center.
Does Planet 9 supposed to have a name yet?
Yes, Planet 9. We call it Planet 9. Yeah.
That's the name right now.
Are people angry because for them they still see Pluto as Planet 9? Oh, I
don't know.
hear some emojis in the audience.
Yeah.
Wait, look, you guys. Pluto is like Pluto. If you take Pluto and calculate its surface area, what you will find is that it is almost exactly equal to the surface area of Russia. And you might make the argument that Russia too is its own planet, okay? But that's the extent of the planethood. Yeah, Pluto is really small. There's a great history of why it was mistaken for a planet, and the reason is when they were looking for Pluto, they were looking for a thing that was 7 Earth masses. Okay, this was the Planet X theory put forth by Parzival Lowell about a century ago. And when they found something, they decided, well, that's got to be it. It's got to be a planet. And when they couldn't resolve the disk, they said, well, it can't be 7 Earth masses because then we would see how big it is. So they concluded it was probably 1 Earth mass. But that's the truth is you can't measure mass by looking at something, right? You have to have a satellite.
Yeah, and
so
the satellite.
Yeah, the satellite was discovered in 1978, and then they were like, oh, this is really small.
Yeah, this is really small.
Piggybacking on what you were saying, why haven't we found it yet? I find it interesting, especially if we consider that Neptune famously found through mathematics, right? We realized a variety of perturbations, gravitational perturbations were happening, little disruptions on other planets, and so Urbain Le Verrier crunched the numbers, sent the coordinates to someone in Germany, and then there it was. Why is this more complicated?
Okay, that's a great question. With the 1846 discovery of Neptune, right, which was discovered from, just like you said, the disturbances it was causing in the Uranus orbit, there were two things working kind of for Le Verrier. Yeah, one, he was way smarter than I am. Okay, so there's that. Okay, but two, in 1846, Uranus and Neptune were a conjunction. So you could, from that data, figure out that something is pulling on Uranus from right there. Okay, you couldn't actually figure out the mass or the orbit, which he kind of guessed, but got wrong by a factor of a couple. Here, you have the polar opposite regime. What we can figure out is what you see on the slide right now. We can figure out that pink ellipse, so we can figure out the orbital ellipticity, the semi-major axis, things like that. And we can calculate the mass. Where is it on the orbit? We don't know. Okay? And so we have to scan a really large patch of sky. It's also 100 million times dimmer than Neptune, so that also is a little problematic.
Now, does it have to reinforce this pattern every once in a while? Because you said it would go away. It would just randomize again in a relatively short amount of time. So why are we seeing it now? Is it come back around and re-put them back in their place?
It is. So yes, but allow me to dig deeper. Okay, the mode of gravity through which this pattern that we see is sculpted is the phase average to what's called secular dynamics. So because everything out there is moving very slowly and incoherently, it's as if those orbits sample the planet at every spot on its orbit and kind of feel the collective gravity of the orbit itself. So even the orbits themselves don't store information on where the planet is. If we watch them go around the sun once, which would take about 10 or 20,000 years, then I'll be able to calculate the phase. Okay, so 10,000 years from now, we'll do another one of these. I'll announce the result. We'll have a big party.
And that's not even that
Come
wide.
on back, everybody.
And technically, that's not even that wide of an orbit. I think there were some exoplanets that were found way further out in comparison to their star.
Absolutely.
So it's decently close to us.
Yeah, I mean, it's just 500 AU. It's practically, like I scoff at how close it is.
Its distance is in LA, right?
That's right.
That kind of thing.
Now, I heard recently that there was some new evidence for its existence, because people are trying to wash it away and come up with other reasons why these larger objects might have been affected, but now you've seen evidence for this in a smaller set of objects. Well, not a smaller set of objects, but objects that are smaller. There's actually a lot more of them.
Right, and a distinct population. So much of what we have been focusing on in the last decade of doing this research is looking at the most distant objects that are the most stable, subpopulation of the trans-Neptunian belt. And so in the last year and a half, really, we thought, okay, well, what about the other extreme? We thought the other extreme, the stuff that's being kicked around by Neptune, is unimportant. But we found out that it actually is. And we looked at the population of the objects whose orbits cross the orbit of Neptune, but are mostly hanging out outside. So in this diagram on the left-hand side, the dotted circle is the orbit of Neptune, and the kind of gray ellipses are the things that are on their way out of the solar system. And what we found is that this population of objects simply would not exist if Planet 9 was not there. Why? It's because they're on their way out. Okay, if you leave the solar system alone for 100 million years, all of this gets cleared out, and you have an empty region of Neptune crossers. If Planet 9 is there, however, it continuously re-injects, its gravity re-injects material from the outer solar system back, causing this steady flux, this river of Kuiper belt objects that cross the orbit of Neptune.
So these are essentially hyperbolic objects that you'd see at Neptune. They're like a hyperbolic.
They're
comet.
almost, they're on their way to becoming, yeah, they're still
hyperbolic, okay.
elliptic, but they're on their way to becoming hyperbolic.
Okay.
Yeah.
Yeah, but
You say 40% chance?
So yeah, there's a 40% chance, without knowing anything, there's kind of a 40% probability with which you would expect that something is out there. And
what do you base that on?
yeah, so that's based upon the calculations of Uranian formation of Uranus. When you do those calculations, 40% of the time you trap something in the outer solar system as well, right? So it sounds like an unrelated thing, but I'm pretty sure that Uranus is there and it's tilted. So that's kind of the logical, I don't know, thread.
So how much of the sky have you actually searched? If you were to just, what portion of the sky have we kind of eliminated? What portion of the sky are you looking in?
So, me personally, okay. All right. There've been surveys that are going all the way around. Like Pan-STARRS is a great example, right? They don't go super deep. They go down to magnitude 22 on a good day, right? But they've sort of searched a huge fraction of the sky. So using those results, you can eliminate the possibility that Planet 9 is at the closest parts of its orbit. Okay, so that's gone. We've also been conducting our own survey using the Subaru telescope. So that's the Japanese National Observatory. It's on Mauna Kea in Hawaii. And we have searched a patch of sky that big.
Yeah.
Okay, that's in 10 years.
Telescope.
Yeah.
So it's large, but it doesn't have a huge field of view either.
Well, yeah, it's the best we've got, right?
Yeah.
It's the best we've got right now. But the good news is that probably next year, right, we'll go to this bad boy right here, the Vera Rubin telescope.
Yeah.
Observatory is going to come online. This is, by the way, not a ChatGPT generated image of the observatory. This is actually what it looks like, so it's legit. And the advantage of this observatory is, unlike what we've been doing for the last 8 years, this telescope, its job is to wake up and kind of scan the sky up and down and then report the data, right? And it just does that every day. And so it's a survey that's fundamentally much more efficient than anything that we've been able to do. Now, it might not go deep enough, so Planet 9 still might hide. It also might not go north enough because it's in the southern hemisphere. Turns out the Earth is not transparent. I'm predominantly a theorist, but I've learned by doing some of this observational astronomy also that the Earth is not transparent. Okay.
And are you using mostly ground-based telescopes for this search?
Yes. The space-based stuff has a tiny field of view. So once we find Planet 9, things like JWST, right, we'll use them to characterize Planet 9. We'll use Hubble to search for whatever.
Nancy Grace Roman will have a fairly big field of view. It might be of some use.
Yeah, absolutely.
You're searching in the infrared, correct?
Are we searching in the infrared? No, we're searching in the visible.
Really?
Yeah.
Yeah, it probably is a very cold object because it's so small. It's not Jupiter-sized to create enough heat. So it's cooled off. So it's not going to give off a lot of infrared. So you're looking for bounced sunlight. Yeah.
Sunlight?
Yeah.
It's been interesting with its mass that, it seems that a lot of the exoplanetary systems we're finding, almost all of them have a super Earth, mini Neptune, and we don't. Is this kind of an answer to that?
Maybe. Yeah, maybe. I mean, there's still, it's an open question as to how exoplanets form, right? Why is it that the dominant outcome of planet formation throughout the galaxy is a 5 Earth mass object? I have ideas and like theories about this, okay? But I will only share them much later in the night, okay? So,
Noted.
anyway, yeah, so that said, one way or another, empirically, 5 Earth mass is the most typical planet. It's weird that we don't have one, but maybe now we do.
Gravitational microlensing?
There's not enough background objects.
Yeah.
That's the problem.
Yeah.
Have any comments? I know that's kind of comments are so small and there's not that many of them that come to visit us, but could any of them be found to have been in some way, gravitationally impacted?
Yeah, I've never looked into this, but there was a paper by a Spanish team, I believe, that have, they made the argument that there's one sort of hyperbolic, I don't remember if a hyperbolic or just nearly hyperbolic comet, and it was coming from exactly where the aphelion of the orbit is. It's a stretch, right? Like that doesn't, you can't conclude anything.
It's just one object, so.
But that said, it's totally coming from Planet 9, you guys. Yes, that's the answer.
So many years ago, I met you at Caltech after a talk that was on hot Jupiters, and I think this was in 2017 or 18, and you told me, we're going to find it in 5 years.
Yeah.
And then COVID happened, right? And that kind of threw a wrench in the plans.
That's right. Some people were coughing, some people were sneezing. Yeah. I vaguely remember this.
Do you have I know that it's almost impossible to give an estimate because, especially now that we've ruled out that it's close to us.
Yeah.
Do you have, in your imagination, in your, crunch some numbers, 10 years, 20 years?
We're going to find it in 5 years.
Excellent.
No, look, so it is an interesting, it's interesting having been involved in this particular line of research now for like 8 years, because I remember back in 2016, right, when we sort of published the first, Planet 9, first couple papers about this, thinking, my God, like Vera Rubin, 2023, we'll have like flying cars and just like the world will achieve some higher level of cognition, and maybe to some extent that's true.
Just ChatGPT.
Just ChatGPT. Yeah, just kind of a regurgitation of the internet. But we're coming up on this interesting moment, right, when this whole field is about to get put into high gear because of Vera Rubin, right? We've never done anything like this before, and so this will, I see really 3 outcomes of Vera Rubin going online. Number 1, it finds Planet 9, we all celebrate, and move on to characterizing it, right? That's option 1. Number 2, it doesn't find Planet 9, and it discovers, a factor of 10, like hundreds of these Kuiper Belt objects, and independently, right, proves and characterizes all aspects of all of this dynamical structure. In which case, we go into a frustrating mode of like dark matter. Like, it's like we gravitationally effectively know for sure that it's there, but we haven't seen it, right? Option 3, it disproves all of this, right? And then, I'll be the first to, explain how we got it so wrong, right? There is a non-zero chance of this, right? It's about 0.003%, but like there is a chance that all of this is wrong.
Well, yeah, if you get a bunch of, don't connect them, but a bunch of pendulums that are isolated from one another, if you set them all on a table, they'll start affecting one another. But if they're isolated, every once in a while they'll kind of all look like they're swinging together, even if they're not. But you have to catch it right at that specific time that it's all doing that. We might have caught all these just at the time they were all doing this, and then they're going to go their own way and never do it again for millions of years. So That's that 3% you're talking about.
It's 0.003%.
0.03%.
Yeah. So it's much less. Yeah. So
this is weird.
It would
These
be
alignments are really
a
weird.
deep state level conspiracy of the outer solar system if that were true. Like that would be kind of the most remarkable explanation. Actually, like it would be the most remarkable thing because there's now about 5 different lines of evidence that all point towards the same planet. Wouldn't it be amazing if all of those like turned out to be wrong? That would be like there's a part of me that kind of hopes that's true, just like the anarchist part of me wants that to be the answer. Okay, there's also another possibility. Imagine Vera Rubin goes online and finds 0 additional objects. Okay, like that's within the realm of possibility. Maybe we've found all of the bright enough Kuiper Belt objects already, right? Then Planet 9 exists, because then all the patterns have been independently confirmed. Okay, so those are kind of the possibilities. One of the most exciting things about doing this is it's essentially impossible for me to put a real intuitive number on like what I expect. All of these are possible. Like we're going to find out, and not in 10 years. We're going to find out in 2 years, maybe next year, on like what's the physical reality of the outer solar system.
Now, could it be a more massive planet further away? Like, is there some range of sizes that this could be?
Yes, there is a range, but now we now have enough. We now have enough objects, and we now understand their structure well enough that we know we can't push that game forever. We can't just keep parking the planet further away and increasing its mass, because the thing that you actually mess up is the tilting of the planes. That's the thing that breaks if you go too massive.
And
Interesting.
Yeah.
with regards to naming conventions,
Yes.
many people in the public may not be aware there are actually bodies that control naming of objects in the solar system. Would you like to?
Yes,
about
it's
that?
very simple. There is a change.org petition, which is addressed to myself and my partner in crime, Mike Brown, and IAU. And this petition asks for this planet to be named David Bowie. And I think it's a good idea, okay? Because look, we like traditionally
Named after gods.
Yeah.
So
David Bowie.
this
It's just
tracks.
like think, right? But yeah, we're out of the Greco-Roman.
Yeah, we've
I
started to
think-
use a lot of them.
Yeah, I think the demigod of untied shoelaces might still sort of be available, but that's like the only one that's left. Okay. Yeah, and
Planet McPlanet Face would obviously be the
Planet
internet's
McPlanet,
choice, but that's why we don't leave
Yeah.
it to the internet.
So, well, let's turn to our audience for a few questions. We have a little bit of time left. Does anybody have a question for our speaker?
this is in Chile. Yeah, I know it looks like there's a homeless encampment there with the blue tarp, but it's in Chile.
It's not finished yet. They're finishing it up, and it is named after the astronomer Vera Rubin, who discovered the evidence for dark matter in spiral galaxies. She extensively observed the velocities of the stars in the outer galaxies, and said there's something making these move too fast. Now, she was uncomfortable with coming up and saying, this is a thing called dark matter. She says, no, I have seen evidence that there's something there causing gravity. But she really probably should have won the Nobel Prize. It was a real shame
absolutely.
she did not win it.
Yeah.
But anyway, we don't want to open that can of worms tonight. Well, we did, but that's
Yeah.
fine. But that's one of the reasons the telescope is named for her, because she was a wonderful astronomer. So, yeah, over here.
Are you using AI to analyze or crunch any of the data?
Yeah, question was, is AI being used to crunch data? Or
Only to write emails. Just we are using a lot of machine learning during the process of actually analyzing the images. Some of the emergent properties of AI are not really right for this problem. For doing the calculations, it's much more kind of brute force numerical integration that does the job. So yeah, it's like I'm really into the remarkable advances that have happened in the last 3 years in transformer architecture, but it's not really useful for this problem.
In fact, I'm going to piggyback just on that question. I asked you earlier if there was any of these citizen projects that have been helping with that. There are a variety of projects. The most famous one was called Galaxy Zoo. The public could go and classify shapes of galaxies, and they've been used for quite a lot now of research projects when you've got a lot of data to analyze. So is there any way that the public could potentially get involved in that?
Yeah, so there's backyard worlds.
Yeah, they did it for brown dwarves as well.
That's right.
I
So
think.
they actually started that project as a way to get citizen scientists involved to look for Planet 9. What they found were a bunch of brown dwarves instead, which is still pretty good.
Yeah.
It's not bad.
Brown dwarfs are objects that were too small to fully ignite fusion in their cores. They never got the hydrogen fusing into helium, but they're bigger than a typical planet. So interesting things.
So it's interesting things. I think ultimately, Planet 9 is kind of out of the realm of what what some of the best telescopes can do, and so I think for the time being, this is not even a professional versus like citizen scientist. This is a oh boy, hopefully this Vera Rubin thing works kind of.
Yeah, it's a thing.
Back to your statistics, I just find this so interesting. So just using now, we figured 40% chance there's that planet.
Yes.
Now with all of the research that you've done, are you like 85% sure you're going to find this planet?
So the formal answer to your question is the latest paper we did, which we published this year, gives a 5.2 sigma rejection of a Planet 9 free solar system. Okay, so 5.2 sigma is pretty good. So that it's the data appears to really be telling us that a Planet 9 free solar system cannot be the answer. And I'm trying to be careful because it's different statement from saying a 5 point, like it's not a detection, it is a rejection of the absence of Planet 9.
And then, so to get to your .003, that none of this is possible, how did you arrive at that statistic?
That's the 5.2 sigma.
Okay, so
yeah. Right? 5.2 sigma is 0.003%.
Yeah, it's like 99.997.
I think there was a question at the top.
Yeah, and the 40% was our solar system should just have one if you make one. So that's without having all the evidence there. I thought there was a question up in the back there that I wanted to get
There's someone at top who's had their hand raised for
Okay, well, we'll go there and then to the back top, and that may be what we have time for. We'll see.
Yeah, that's me. The question was, would we expect it to be another kind of gas giant, or could it be terrestrial in nature? I heard you say super Earth.
Yeah.
And what would you estimate?
Okay, so one of the exciting things is we have no idea, right? We have no ability to calculate the composition of this. All we know is mass, and like it could be a 5 Earth mass burrito, like I mentioned earlier. Like that would do the job. But what should we expect? Okay, should we expect it to be a burrito?
Probably not.
Maybe, but I would argue that we don't know what to expect, because every time you go through the process of calculating, right, when this object should have formed, you run into the problem of, okay, if it formed while there was gas around in the solar system, would it have captured an atmosphere that's sufficient enough to inflate its radius? Maybe, but then during the ejection process from the solar system, did the headwind, the shock from the headwind, blow off the atmosphere? Maybe. Like we really go into a lot of speculation, and so one of the frustrating things was we don't even know how bright it is, because we don't know if it has an atmosphere. We don't know how big it is. That's all we know is the mass.
Yeah, in some ways it might be better if it doesn't have much of an atmosphere, because then its albedo might be brighter, because it could be icier, versus something that's thick and gassy and just dark.
But ice,
I don't know.
Ice, when it's particularly organics, when irradiated by cosmic rays, turn really dark and
dark,
gunky.
You're right.
And so who knows? Yeah. If we don't find it, it's because it's too dim. Trust me.
Yeah.
Over up there, yeah.
So based off of all of your observations, what's the likelihood that it's going to have its own unique satellite?
Okay.
The question is what are the chances it'll have a moon, essentially?
Yeah. The same, it's like somebody when I was a teenager blew my mind once because they said, what are the chances you will meet a dinosaur outside? And I said, I don't know, like 0%. They said, no, it's 50. You either will or will not. Okay, so it's kind of like in that same realm.
Interesting statistics.
Yeah, Jupiter, Saturn, Uranus, and Neptune all have satellite systems. Naively, we should expect that everything has a satellite system. That said, the search for exomoons has come up empty. So it's really like this is one of these things where we just don't know. I hope it does so that we can image the satellite, measure its orbital period, and immediately calculate the mass so that I know if I'm right or wrong in the theoretical calculations. But whether it has a satellite or does not affect any of this. So this means that there's no way to compute the probability that it does.
Yeah. Interesting.
What if it were two objects like Pluto and Chiron?
Yeah.
Around a common center of mass, if they were relatively.
That'd be cool.
That would be super cool.
That'd be sweet.
So.
Yeah.
Well, thank you so much for this update. Hopefully you'll have an exciting update of it was found maybe 6 months after Vera Rubin comes online. We'll
all right.
Cross our fingers on
Not
that.
in 10,000 years.
Not in 10,000 years, exactly. But thank you so much for joining us. This has been a real pleasure tonight. Thank you. So again, I want to remind folks, come on back on November 15th. Dr. Robert Papalardo will be here, project scientist from the Europa Clipper mission that just launched NASA JPL. As always, All Space Considered thanks you all for attending and watching online. The program is brought to you by the City of Los Angeles, Griffith Observatory, the Department of Recreation and Parks, and we always like to thank our exclusive nonprofit partner, Griffith Observatory Foundation. Thank you, everybody.
Thank you.